No problem. Ready to go.
Good. So you can start whenever you're ready. Thank you. And enjoy to everyone.
Thanks, Pranima. Hello, everyone. Welcome to our partner meeting this year. And today at the technology channel, we are going to introduce you about high-rate concrete dove as one special example for our dove range, and also aerobic treatment by Tanya. Idols and sludge dewatering will also coming up in today's session. Actually, idols will go right after the dove session, so we have also an overview of the dove primary treatment. So we have before we start, our main technology sessions are handled by our product managers team that is relatively new for Nijhuis. The reason for that is we want to support all our sales service and also our agents partners to have a better understanding with our technology and and also learn from you what's required in the market. And we hopefully can answer your questions in a more efficient way. And we've made a selection of prioritized products, including the topics we are going to cover today. And so if you have competition informations, and if your client or yourself is looking at any business case for a specific client, that's something we can process together, because we also develop tools for that, understanding how long it will take for the client to get the payback period. And so the question regarding of the products, we will be an interface between you and also our technical team. So we have a wide range of dove systems, dissolved air flotation systems, and there are many of application that is applicable using a flotation way to do the treatment of our wastewater. And so in principle, it can be categorized in two type of application. One side is we implement play packs and make sure that we have a smaller footprint of the dove unit, and also enhance our separation efficiency. The other side is when the pollution level is getting very high, then we make to avoid clogging, we are using the open tank type of flotation system. And today we are looking more focused on the high-rate concrete IDAV. That's also something we have a successful case that we would like to introduce with you from Singapore. So again, like the left-hand side, we have IPF, NPF, and also high-rate concrete IDAV. Those are the dove systems with play pack in it. So in this type of application, it's quite unique, and to reduce the footprint of the unit size, and that brings us special benefits, especially to the drinking water and algae removal market we are talking about today. For this type of application, there's a lot. Typically, we are treating a large flow of water coming into it, and in order to prepare the water going into the membrane system and produce the cleaner water at a downstream. And by using the playpack technology that Nijhuis is specialized with, we can highly reduce the unit size. Like here, we can see in the table that floor hydraulic loading rate, we can reach up to 60 cube per square meter per hour, compared to an open tank type of technology that is in our case used for other application, but that also deviates our standing point compared to other concrete dove in the market, because playpack is quite unusual and quite unique for the drinking water and algae removal market. So why we are talking about algae removal and drinking water application is because we see that actually it's a global issue. Around the world, there are many places they are facing water stress. And because of that, it's important to get enough clean water source. And in order to produce that, desalination plants is developed for many countries or regions in order to produce the drinking or processed water they need, especially when they have a water scarcity issue locally. But on the other hand, there are also seasonal algae bloom in the ocean water that can cause clogging issues in the downstream membrane or the treatment process. So it's important that we always have an efficient pre-treatment upfront, and that requirement is getting more and more awareness in worldwide. So we often see in the market that some people are using settler, or some people are using DUF systems without playpack, but many of them fail to deliver, getting more and more challenges to deliver the right effluent quality going to the membrane system. And that's a strong point that Nijhuis can enter the market. The unique selling points of our concrete DUF is that we have, because of the playpack system, we separate the air bubbles from the effluent. So there's no air bubbles trapped into the effluent. That I will come back to later why we can manage that. And also we have high performance because of the stability of the flow distribution in the tank. So that will also guarantee a better effluent quality and always make sure that we have the right performance. And the other part, apart from the right water quality going to the membrane system, we also, by using the playpack technology, we reduce the unit size highly, because when we see here, Nijhuis playpack, we can go for up to 60 meter per hour, compared to a conventional without playpack, it can be as low as 25. That is the market are used to, but when you have space limitation and you are looking for compact solutions, Nijhuis concrete DUF is something plays an important role in it. So having a smaller unit not just reduce the size, but it also lower the total capex for simplified civil work for it. So when we look at Nijhuis concrete DUF side by side with the conventional concrete DUF without the playpack, our playpack enhance the separation, no air bubbles going into the effluent, so no clogging issues or downstream hazard because of that. The unit size is highly reduced because of the increased separation surface by playpack. And we have the 3-wheel skimmer, I will come back to that later as well, that minimize the sludge backflow. So also another way to guarantee that we have a good effluent quality. The infiltrability, we also can handle a higher range, and we also have a smart effluent control to make sure that we have we are capable to handle a fluctuating flow size over time. This characteristic I will show in the coming graph. So here we see that this is a 3D model of a concrete DUF. The flow goes in from the left, the blue box distribution channel going into the concrete tanks. It goes through 2 reaction chambers, and then it goes to the flotation side. At the flotation chamber, you see that at the lower part, we have the playpack series. We have the playpack, corrugated playpack that creates multiple separation surface that increase the separation quality and also reduce the flotation size. So this is why we can build a smaller size in our concrete DUF to handle the same flow. And at the top, we can see from the left, we have the clog-free aeration that is quite unique also for our DUF range. And especially for the concrete DUF, that's also unique for the market, is that we have the 3-wheel skimmers. We actually learned a lot from our stainless steel DUF technology and take all the advantages, put it into our concrete design. And that's something unique for the concrete DUF market. And at the end, the water going out at the blue box at the right, and it is controlled also by a smart effluent valve. And the reason for that, I will come back to that too. And the separation can be done by 2 ways. One is the typical way the bubbles capture the solids at the top and removed by the 3-wheel skimmer. And the other way is that if there's really some settling particles in the unit, it is also optional to have suction pipe or a bottom skimmer to remove the settlement. Here is some pictures of how we really build it. We have already realized a couple MEDP desalination plant in Singapore. And so we got a satisfied client and they are happy with the effluent quality and the operation. And this is really a launching moment for the market to see that, okay, Nijhuis really know how DAF system is working, and they know the application, how it can work to deliver the right deliverables. The concrete DAF is composed of several bays in parallel. Each bay can go up to 3,500 cube per hour. And the concrete basin is composed, like the previous slide, from the left to right, we have 2 reaction chambers and also 1 flotation chamber. And we dose our coagulant acid upfront in the static mixer, and the modular designs make sure that we can always expand it parallelly. So, yes.
I'm sorry to interrupt. I just want to remind you that you have 5 minutes left before you go to the Q&A.
Yeah, good to know. Thank you.
Thank you.
So the first special feature of DAF is using our plate pack, and that is the flotation chamber at the lower part we can see in the graph. The advantage from it is that it creates multiple separation surfaces compared to without plate pack. Then we are counting on only the surface at the surface of the unit itself. So by increasing that, we have a more compact unit size. The size of the unit is highly reduced compared to without plate pack. And also we have optimized a separation without a bubble in the effluent. Like how we can achieve that by looking at the lower left graph, we see that there's a dark blue zone. This is the same zone where the plate pack is situated. Here we make sure that the velocity is getting so low that all the settlement, all the bubbles going into the plate pack zone, they can being subtly going up flotation without any disturbance in the unit. You see that with upside of the plate pack zone, there's a different flow velocity, but the static part in the plate pack zone make sure that the flotation part always go up and being separated, not being collected by the effluent at the bottom of the unit. And also the settlement can go downwards and being collected with other systems. So we have more than 2,600 project references with plate pack technology, and that's what we bring to the desalination market. So this is a quick animation to show that without plate pack, what's a typical or conventional way that a particle needs to take a long path in order to get being skimmed off and separated from the water. But if we create, imagine that this is not the realistic one, because most of the our plate packs, of course, is tilted, so all the solids can be captured at the top. But here, just to show that by putting multiple layer of the plates, then we make the route of separation much shorter compared to without. So it's easier that it already reached the separation phase, and it takes much shorter time and shorter route. That's why we can reduce the unit size. So it's like having, let me see, having 1, 2, 3, 4. If we are dividing the whole unit into, or the separation zone into 4, then we are increasing also or reduce the size by the factor of 4 as well. So this is, so in reality, the plate pack is put in an angle. And how does it achieve a static low velocity flow? Is because you see the 2 gray parallel part are the plate packs. And because next to the plate packs, the flow is so low, so the bubbles can rise as it wishes and not being taken downwards to the effluent capture department. The second part, I'm running out of my time. The second part of the feature is that we have a 3-wheel skimmer. This we make sure that at the right side of the skimmer, we see there are two wheels. Make sure that we always have an optimized skimming system, and make sure there's no sludge backflowing into the unit. In that case, we can make sure that our water quality being collected at the bottom of the unit is always clean for the downstream membrane treatment. The next one is smart effluent valve. This way we control the water level inside of the flotation unit by controlling the effluent valve. So in this case, no matter how much flow going into the unit, there's a certain range. We can always make sure that the water level is always at the right level, so it can be skimmed off optimally. Last but not least, we have the clock-free aeration system. This I don't dig into details because of time, but in comparison with other aeration systems such as saturation vessels or aerated pump, we are looking at more clock-free, so free of mind of operation. And also, we don't need to apply for a special certificate for the saturation vessels like that they need to do. And in case when the flotation is not, in very rare cases for the algae removal, most of the algae can really almost completely removed by flotations. But in case the inflow also have some settlementations that will going to be settled in the unit, we are also offering different optional systems, such as a suction pipe to get rid of the sedimentation, or a button skimmer that we can get rid of the sedimentation. So before the end of the presentations, this is the case we had before the Singapore case. We already have algae removal experience, and that already dates back to 2006. So we have more than 14 years of algae removal experience up and running. And by applying this experience, we launched our first concrete reference in Marina East desalination plant in Singapore. This is Singapore's fourth desalination plant with 137,000 cubes per day of drinking water produced. And it's already up and running since June last year. And it's possibly the first also having the design applicable for both the seawater and the sweet water, so the non-salty water going as an inflow. So it's up to the plant what they want. And this is where it's located in Singapore, and it takes quite a distance. At the number one, here is where we can choose whether we want to take the water from the ocean from the right down angle, or from the sweet water from the reservoir in Marina. This is how it looks like. And this is the first part of our technology presentations. Thank you for your attention. In case you have any questions, please leave it in the chat, and we will see what we can deliver and